Hello, welcome all to Anudeep, your YouTube Sustainability channel. We have started with the discussion of the topic called integration in the previous lecture, and we have seen the problem which are based on the direct formulae. Today, we are going to discuss about the problems which are based on the substitution methods. So let us understand few basics before we proceed. In the substitution method, we suggest you to substitute the value of x so that the problem simplifies. As you can see on the screen, it is root of a square minus x square. So if we substitute the value of x as a sine theta or a cos theta, then you can take out the common a square outside and you get 1 minus cos square theta or sine square theta, and then you can simplify the problem further. So that is what is advisable thing. If you see root of a square minus x square, substitution can be a sine theta or a cos theta. Similarly, if you have root of a square plus x square, x can be replaced with a tan theta. And if it is root of x square minus x square, substitution of x is equal to a sec theta may help you. Now on the screen, another form of the integral is given to you. And if you see the form of 1 over ax square plus bx plus c, or 1 over root of x square plus bx plus c, we take out a constant from the denominator and we rewrite the terms, and then we see if we can express the given quadratic in the form of the perfect square. Like we find out what is called the third term, and for that the formula is given as third term is equal to 1 upon 2 coefficient of x the whole square. So in this manner, after expressing the denominator as a perfect square, you get the form of a direct standard formulas that you can apply. So you can identify it and you can apply that. You see the another form of the integral, that is 1 over a sine square x plus b cos square x plus c. Here you can divide the denominator and numerator by cos square x and sine square x, and then you replace tan x as t or cot x as t, and in the denominator you replace x square by 1 plus tan square, and then you do the substitution. And when you substitute tan x by t and simplify it further, you can get the required integral in the standard form, and then you can solve it. The form of the integral that you are seeing on the screen is very much asked in the board exam, so it is advisable to learn this form and substitution needed for to simplify the problem. So if you see the integral of the form 1 over a sine x plus b cos x plus c, substitution is tan x by 2 as t. You replace dx by 2 dt upon 1 plus t square. If it is sin x term in your integral, it is replaced by 2t over 1 plus t square. And if it's cos x, then it is replaced by 1 minus t square upon 1 plus t square. So now, as we have discussed about the method to solve problems using substitution method, and we have discussed about various forms where this method is applicable, let us solve the problem on the screen. Here you have been given 1 upon root of a square minus x square. So the substitution suggested here for x is, you can put x is equal to a sine theta and solve. So the method says when you are substituting something as a new variable, you have to get the variable differentiation with respect to that variable first, replace it with the old content and rewrite the problem in totally a new variable that you have used and solve it. So let us proceed. We are substituting x is equal to a sine theta. So what will be the value of theta here then? Theta equal to sine inverse of x by a. Again, when I differentiate this, what I will be getting? Differentiating both the sides, we get dx is equal to a sine theta. Derivative of sine theta is cos theta. So a cos theta d theta. So these are the things that we are going to replace in the original problem in equation 1. Wherever there is x, you replace it with a sine theta. Derivative of x, that is dx, with a cos theta d theta. Right? So let us proceed. So now my problem becomes, it is 1 over root of a square minus x square will be a square sine square theta, and the value of dx is a cos theta d theta. So what I will be getting here? A cos theta will be as it is. Here, if I take a square common from here, I will be getting a square 1 minus sine square theta gives me a square into cos square theta. This term will come under the square root sign. When I take the square root of this term, it simplifies to a cos theta, and this d theta will be as it is. So now my problem gets very much simplified. I have a common term in numerator and denominator. So what remains inside is d theta, and integral of d theta is theta plus c. But from equation 2, I get the value of theta is sine inverse of x upon a plus c. So what is my left hand side? It was integral of 1 over root of a square minus x square dx will be equal to sine inverse of x by a plus c. And if you can recollect now, it is the standard formulas that we have learned beforehand, right? So in examination, you may be asked question for 4 marks for its derivation. So these are the standard formulas like 1 upon x square plus a square, 1 upon a square minus x square, 1 upon root of a square minus x square. All these problems can be asked for its derivation, for its proof in your exam for the 4 marks. So this is how we are going to solve this. Now let us look at the second problem on the screen. Here we need to think about the substitution by which we can get the derivative of that term exists inside the integral. So if I can think about sine 2x, so it is a multiple angle formula, and I remember that what is the value of sine 2x? It is 2 sine x into cos x, right? So that gives me hint that if I substitute sine x as t, cos x dx is my dt, right? So instead of that, I need one additional term, that 2 sine x. So instead of sine x simply as t, if I substitute sine square x is equal to t, that solves my purpose. What is the derivative of sine 2x? It is 2 sine x cos x dx is equal to dt. And this is exactly what I am looking for. So that strikes me, or that advised me to select sine square t as the substituted variable. So here again, what I am getting after substitution is wherever there is sine 2x, I am going to substitute t, and wherever there is derivative, I am going to replace it by dt, simply the derivative term. So now my problem changes to sine 2x dx. It is nothing but sine 2x dx is equal to dt. So my numerator changes to dt, and in the denominator, what I am getting is sine square x is t. So sine square of square, that is, it will be t square. So sine raised to 4x will be t square minus 4 sine 4 into t, that is sine square x is equal by t, and plus 1. So it simplifies my problem, isn't it? Now look at this. Here again, we cannot directly apply the formula. We need to calculate what is the third term here. So before that, what I can do, I can take these 3 out. We have already discussed about this method. So 1 upon 3 outside, what remains is inside is t square minus 4 upon t plus 1 by 3. Now to make this term a perfect square, we find out the third term. And the formula for third term is 1 by 2 coefficient of middle term square. So that gives me 1 by 2 into minus 4 upon 3 square. 2 2s are 4. So it gives me 4 upon 9. This is the third term. So when you add and subtract, what you get? I is equal to dt upon, it is equal to t square minus 4 by 3t, and third term just now we figure out it is plus 4 by 9. As we are adding, we need to subtract the same term, and plus 1 by 3 was already there. So when you simplify it, what you get? The first 3 terms, they are nothing but the perfect square. So it is t minus 2 upon 3 the whole square, and then when you calculate by taking the LCM, it comes out to be minus 1 upon 9. So I can write it is minus 1 upon 3 the whole square. Now it is of the form x square minus a square. So I can recollect the formula for integral of dx upon x square minus a square, and that is 1 upon 2 into a. A is my 1 by 3 log of x plus a, that is 2 minus t minus 2 upon 3 x minus a upon x is this term plus 1 by 3 plus c. So what I will be getting is, now here it is 3 upon 2 log of, so what we are getting, it is log of t. What is your t? Again 3 is common. If I multiply throughout by t, what I will be getting is 3t minus 2 minus 1 upon 3t minus 2 plus 1 plus c. So here final answer, I can resubstitute the value of t, and what I will be getting is 3 into, what was t? It was nothing but sine square x. So t 3 into sine square x minus 2 minus 3 will be minus 3 upon 3 into sine square x, and this will be minus 2 minus 1, and that is what is the final answer. So in this problem, we have not just only substituted by thinking what should be the substitution. Again, to simplify it further, we calculate what is called the third term, and lastly we have applied the direct formula for 1 upon x square minus a square. So you have to calculate all the formulas that you have to study. Think at what step which formula you are going to apply and proceed. Now in this problem, you have been given the term of 1 upon 5 minus 4 cos x. Like we have discussed this form of integral before, and it is suggested that if you see this form, that is 1 upon a cos x plus b sin x, or maybe constant with cos x and sin x in the denominator, it is advisable to go for this substitution. And what is the substitution? You substitute tan x by 2 is equal to t. You have to replace dx by 2 dt upon 1 plus t square, and cos x as 1 minus t square upon 1 plus t square. So let us proceed with the substitution now. So our integral becomes, after this substitution, you get numerator as 2 dt upon 1 plus t square, and in denominator you have 5 minus 4 into 1 minus t square. I am replacing cos x by this value plus 1 plus t square. Take the LCM, you can see 1 plus t square is common in numerator and denominator. We are going to cancel it off. So what I get here, 2 is a constant, taking it outside. Dt upon, I am cancelling this, so I have to take LCM in the denominator. It is 5 into 1 plus 5 t square minus 4, I am opening the bracket, so minus 4 plus 4 t square. That simplifies my problem. So it is dt upon 5t square plus 4t square, giving me 9t square. 5 minus 4 giving me plus 1. Now again 9 I can take it outside as a common from the denominator. So what I get is t square upon 1 upon 9. And I can write 1 upon 9 as 1 upon 3 the whole square. Now as you can guess correctly, yes, it is of the form dt upon x square plus a square. And what is the formula? It is, what is the formula for integration of dx x square plus a square? It is equal to 1 upon a tan inverse of x upon a, right? So here, what is my a? A is 1 by 3. So what I will be getting, I is equal to 2 upon 9 into 1 over a. That is 1 by 3 tan inverse of. Now, what is the value of x? X is t here, and a is 1 by 3 plus c. So 3 3s are 9. So 2 by 3 tan inverse of this 3, I can take it in the numerator. So it is 3t plus c. Again, now original value of t, what was t for us, is nothing but tan x by 2. So the final answer is 2 by 3 tan inverse of 3 into tan x by 2 plus c. This is how we are going to solve this. Let us look at the next problem on the screen, and bear observation that you can identify this problem is of definite integral, right? So in the previous lecture of mine, we discussed about the two types of integral, indefinite and definite. So if you see the limit over the integral sign, it is a definite. And as I told you, it is exactly the same step that you need to carry out. Only things after evaluation you are going to apply the limits, and the way to apply is upper limit minus the lower limit. So let us simplify the problem. This is again on the substitution method. So if I can just observe, if I substitute the denominator 1 plus sine x is equal to t, I can get cos x dx is equal to dt, right? And that is what is a term that is present in the numerator. So I can very well apply this method. But here, in case of definite integral, there is one additional term that you need to carry out. That is, you need to calculate the limits for the new variable that you are going to substitute. So which is the new variable? T. Which is the old variable? This is the limit for x, right? So we need to calculate what is the limit for the new variable t. So this is what we will be doing. So lower limit, upper limit is 0 and pi by 2. And to get this value, what we know, t is 1 plus sine x. So if I substitute the lower limit in here, sine 0. So what is the value of sine 0? Sine 0 is 0. I am getting it 1. So 1 plus 0 is 1. So the lower limit is 1. And when I substitute, t is equal to 1 plus sine of pi by 2. That is the upper limit. What is sine pi by 2? Pi by 2 is 1. So 1 plus 1 giving you 2. So the upper limit becomes 2. So now with the new limits and with the new variable, we can rewrite the problem. It is 1 to 2. Cos x dx is nothing but my dt over. And now whole of this denominator I have substituted as t. So it becomes t cube. Now I have to take t cube in the numerator. So it will become integration of t raised to minus 3 dt. And when I apply the formula for standard formula for x raised to n, that gives me it is equal to t raised to minus 3 plus 1, that is minus 2 upon minus 2, and the limits that I have to apply. So minus 1 by 2, I can keep it outside, and it will be 1 upon 2 square minus 1 upon 1 square. So 2 is my upper limit minus the lower limit. Wherever there is a variable, you replace it with the number. That is how you apply the limits. So what I am getting here is minus 1 upon 2. It is 1 upon 4 minus 1 upon 1. So it is, when I take LCM, it is 1 minus 4. That is minus 3 upon 4. So answers become, it is 3 upon 8 is your final answer. So I hope the problem that we have discussed today, they are clear to you. So the problem which are based on substitution method, they need some sort of clarification in your mind before you start proceed to solve it further. Because you need to understand which particular value of the part of the integral you substitute, so that the second part is its derivative. So if fx is there, if f dash x, then its derivative exists, then this problem can be solved by the substitution method. So if you find this video helpful, please like, comment and share, and stay tuned for the next interesting topic called integration by parts. See you very soon. Thank you.